reporting for flaky tests would be the next thing we need to tackle, because right now reporting for multiple test executions doesn't result in like a first-class flaky result yet. If you look at JUnit or Jenkins or the Gradle command line itself, it'll just show duplicate test executions because flaky test is not like a first-class outcome for almost all tools. So it's really difficult to capture and report this by yourself. And so while we, the Gradle team, work with other tools to make flaky tests a first-class concept, we've improved Gradle and Maven build scans to collate multiple executions of the same test and mark that test as flaky when there is at least one failed and one passed outcome. So you can see here, this is a picture of a build scan with the same test. You can see samples runner integration test, and it says running sample check on a remote service. The first execution failed, the second one passed, and so this test was marked as flaky. And of course in build scans, you can also see things like the infrastructure that are on the build, for like the JVM, the operating system, the memory arguments and so forth. And you can also get a sense of the dependencies. And by the way, this is free. You can, if you just add --scan for Gradle or the Maven extension, you can do this and it will report flaky tests today. All right, but test retry by itself is just a fancy way of ignoring tests, in my opinion. You also have to treat the underlying problems. Second and final poll. I'm curious to know, what data do you collect about your flaky tests? The majority of folks said they don't collect data on flaky tests, which reflects my understanding of the ecosystem as a whole. Folks don't often understand how many flaky tests are really affecting them and how often, but this is really crucial for actually prioritizing it. Now I'm going to demonstrate to you how Gradle Enterprise will help you track and analyze flaky tests. So this is Gradle Enterprise. It allows you to collect and analyze persistent and shareable build scans for all Maven and Gradle builds, including local ones. With this data, you can drastically improve your build performance and reliability. I'm going to take a deep dive into the test analytics we've recently introduced and show you just how effective retry can be compared with analysis. So let's take a look at all build failures in the past 10 days for this 30,000 builds in an example team. Over in the upper left here, we can see that there were 826 build failures in the past 10 days. Now, Gradle Enterprise will group your build failures semantically by cause. So we can see the top failure here with 639 build failures is there were failing tests. So we click into it and we can see, yep, 639 build failures affecting 2 users on CI on 187 hosts. And we can kind of get a sense of the common traits for these failures. And we can kind of see here, 100 failures a day or so on weekdays, but then it kind of drops to very few in the past few days. Now we can take a look at the test dashboard to understand why that is. So I click to the test dashboard and we see 650 builds with failed tests, which is slightly higher than the number we saw before because not all builds with failed tests actually fail. You could say, oh, well, these test failures are ignored for some reason. And if we look closely, we see, again, 100 build failures or so early on in the week, but then it drops to a very low number. And conversely, if we look at the flaky tests per day, builds with flaky tests, all of a sudden it jumps from nothing to 100 or so, 50, 107 per day recently. So why is this? Why would this be? Well, it turns out that the overwhelming majority of the build failures were test failures, and the overwhelming majority of test failures were flaky test failures. So you can see just by adopting the test retry plugin, and now we have these analytics to show like how many flaky test failures are happening. By the way, this is real. This is the Gradle team's builds. So we get a listing here of the most failed and most flaky tests. I have it sorted by flakiness right now, but we can kind of see here are the classes that report the most failed and flaky outcomes. So this one looks good, like 18% of its executions are flaky and 9% fail. Let's take a look into that. All right, so This is the single test view for the test dashboard, and you can kind of see, over time, it looks like this is not a new problem. It's been failing and then it became flaky, so it's not recently introduced. Similarly, you can kind of look at the test performance, been about 5 seconds per day. It looks like it jumps up a little bit recently, and we might want to dig into why that is. Down below here, we see the individual methods in this test class. You can see that there's 2 right at the top that are clearly the overwhelming majority of failed tests. And it looks like they might be related because they have a very similar name. So we can click in onto each individual test and see its reliability and performance distributions, as well as all of the builds it participated in. So nothing surprising here. Although if you look at the performance, you can see a decent uptick here on January 21st. We see the 75th percentile time has spiked a little bit. So there might be kind of a performance problem here. Now down below we see a listing of all of the builds. Here's all the recent flaky and failed executions of this test. So we can scroll down and it was just failed and then it's only flaky. And we get a sense from the duration, we know when was the most recent occurrence, and we can extend our time range to the beginning of time and see when did it first fail, when did it start getting flaky. And we also show, give you tags to say, here's where this is happening. Is it on CI? Is it local? What are the host names? And so forth. And you can compare failed and flaky executions of this test across builds. So you can say, okay, well, you can take a look at this flaky execution took 1.36 minutes and the past execution took 2 seconds. So there's clearly something going on with the performance sense here, like something's getting locked where this is just waiting for 90 seconds and timing out. You can kind of already tell that from this. So we can take a look at the individual build scan for any of these executions, and we can say, okay, well, we see that this had 2 executions. The first one failed and took 1 minute, and the second one passed and took 4 seconds. Okay, why did it fail? Wait timeout exception. Condition could not pass in 15 seconds. Okay, and then we can see in detail what caused the timeout through this. We'll go back, and maybe we can take a look at another flaky test execution and see, was that the same? Yep, looks like it's the same. So we can kind of see, like, there's something we can, from the group of these tests, we can kind of start to analyze the patterns inherent to this flakiness. You can kind of categorize it. Is this a resource leak, or is it something like test ordering, for example? One thing we can also do that's neat with this is that we can search for any set of tests that we want. Often tests in the same class or also in the same package, when they are failed or flaky, they're usually related. So we can kind of see, I've now told Gradle Enterprise, hey, I want to analyze all tests in this package. So if you have a package that you're responsible for, or you want to look at all browser tests, all performance tests, any arbitrary sort of logical grouping of tests, you can analyze them together and see, okay, well, they've gotten slower or faster over time, they've gotten flakier or failure over time, and then you can dig into each one and kind of see what's common between these failures across all these. Gives you kind of a view into your test that you just have not had before. Now we've kind of started to do the hard work. Now we've detected flaky tests. Now we want to fix them, and we can use build scans and build comparison to kind of investigate that flakiness.